Every week brings a new model, a new update, and another daily wave of headlines about machines coming for our jobs. The modern workplace can feel like a flood of data we are failing to navigate. Consider a young professional we'll call Arav. He looks at this landscape and freezes. He assumes his only path to survival is to memorize thousands of lines of code and become a hyper-specialized machine himself. That assumption traps us in a race we cannot win. Instead of asking how to outcompute a machine, we need to look at what human traits actually appreciate and value when computation becomes abundant. The future belongs to the adaptable thinker, the person who can step back, connect ideas across different fields, and solve human problems. We call this person an AI Generalist. They understand core concepts, connect them across domains, and apply them to real-world tasks. You see this in action when a doctor uses machine learning to spot patterns in patient charts, or when a teacher designs a new grading workflow. They are using an external tool to magnify their own domain knowledge. Getting there requires a structured path. Think of it as a ladder with 8 rungs. You start at the very bottom with basic human curiosity, climb upward through concepts and capabilities, and eventually reach character at the top. You do not need a degree in computer science to take that first step. You only need a commitment to start with absolute clarity, stripping away the complexity until you understand the basic working parts. The sharpest tool for finding that clarity is first principles thinking. When a new technology arrives wrapped in dense jargon and marketing hype, this method cuts straight through the noise. You break the intimidating machine down by asking 4 questions. What is it? What is it for? What is it made of? And what must be true for it to work? Apply this exact method to any new AI platform. Remove the illusion of magic, and you are left with a system that takes a specific type of input, processes it, and generates a specific output. By taking this step before you build workflows, you protect yourself. You prevent yourself from being intimidated by speed or manipulated by polished answers that might actually be wrong. This approach also dismantles the biggest barrier for most people: mathematics. Math is a language invented to organize patterns, helping us describe quantities and relationships with precision. This page outlines the mathematical ladder behind AI. Numbers measure things. They become vectors, transformed by matrices, while probability handles uncertainty. When a model predicts incorrectly, it uses these steps to adjust its weights. This process, optimization, mechanically reduces error over time. Tying these concepts to a specific purpose makes them manageable. AI functions as a structured mathematical system that identifies regularities in data. With the mystery gone, you build practical skills. You ask precise questions, prompt with tight constraints, and read outputs critically. To manage this, you can use a tool card. For every application you use, define exactly what data goes in, what action it takes, what risks are involved, and where a human will step in to review the work. Reading about these tools will only take you so far. The learning cements itself when you build small, low-stakes projects that solve a real problem in your day. True capability requires a person who understands the context and uses their judgment to apply a tool's speed safely. Which brings us to the top rungs: contribution and character. As technological power scales up, the boundaries we place around it must scale up equally. Deploying these systems without oversight introduces severe systemic risks. We see structural bias in data, the rapid spread of misinformation, and users outsourcing their thinking entirely. To combat this, keep a mistake book. Write down where you or the system failed, why it happened, and how to fix it. This treats errors as valuable data for systemic repair, rather than evidence of personal shame. No automated system should operate with total freedom. You must establish permission levels, ensuring a human being reviews the output before any consequence leaves the room. Responsibility functions as core architecture. It creates conditions that make any automated system worthy of trust. This reveals the exact human edge machines cannot borrow. Emotional intelligence, a working conscience, and moral care remain strictly human traits. A large language model can assemble words with perfect grammar, but only you can arrange meaning, sense context, and protect the dignity of those involved. This shifts the relationship. AI takes the role of a disciplined assistant, a tool that requires human presence and lived experience to remain effective and safe. Returning to Arav, the panic is gone. By climbing the ladder, he is no longer reacting to a foggy landscape. He is navigating it with a specific method, choosing how to contribute. The future belongs to the person who remains curious, keeps their judgment intact, and simply takes the next true step.